Everybody, welcome. My name is Spencer Schneidenbach, and I'm here to tell you about a maintainable, opinionated, emphasis on opinionated, right, way to build applications using ASP.NET Core, specifically REST APIs, or APIs in general. Can I get a quick show of hands? How many people are using ASP.NET Core today? Okay, a few of you, good, good. How many are using, I'm going to use this a lot, old ASP.NET Web API? Like, I don't think it's old, I think it's awesome. Cool, a lot of you. Okay, so what I'm telling you today, I mean, it has core in the title, but everything I'm telling you today applies just as well to ASP.NET Web API. There's a couple of things you need to change. Other than that, it's pretty much mostly the same. So if you have any questions about anything, please reach out to me. I have my contact information on the slides. So, and at Schneidenbach on Twitter, so it's a good way to get a hold of me. First thing that I have to say is that my co-host Heather and I are doing a interview show with some of the top speakers here at NDC, and it's coming July 15th, so keep an eye out for it. We've got some really cool things. They teach you something in 5 minutes. It's awesome. Okay? Housekeeping thing number 2, because I already talked about PubConf, right? Awesome. Everything that you see, everything that I'm telling you, you can at me on Twitter, at Schneidenbach. You know, I wouldn't, try to spell it if you just take a picture, right? Or you can go to rest.schneids.net. The precursor to this talk, which is RESTful API design, which was given at NDC, that recording is available. I highly recommend you watch it if you are looking to create your own REST API. And everything that I'm talking about, all the resources, everything at rest.schneids.net. I don't get paid to say that, even though it's my website. There's no ads, so I'm not making any money. It's really to help you. All the resources, rest.schneids.net. Okay? Awesome. So let's set the stage a little bit, right? So your boss comes to you. You're a web developer. There's a lot of ASP.NET developers in here, which is awesome. I love ASP.NET. And he or she says, we need a new single-page application, right? Or we need a new REST API. We needed something that our customers want to be able to consume. They want to get data out of our API. They want to create data inside of our application. We want to create a system where they can integrate really well. I'm an integration specialist, so that's like really important to me. So you say, awesome, okay, I can do that. I'm a discerning developer. I know exactly what I need to do. I'm going to fire up ASP.NET Core, right? Or old ASP.NET Web API, right? Old, because I still use ASP.NET Web API. Out of curiosity, how many web forms people here? This is my favorite question to ask because inevitably there's like a couple of hands that like creep up silently, but they don't want to admit it. But look, I'm a web forms developer too, okay? Awesome, right. And I saw another guy over here, right? So web forms, you probably can't do this stuff, but still cool to use, right? Maybe not, but anyways, I just like to ask that question. So old is relative. Again, all of this applicable to ASP.NET Web API, right? So you're going to choose one of those two things. And you want to go from 0 to make magic happen as quickly as possible, right? Like you want to see something on the page. You're an Angular developer, you're a React developer, or you want to see a record go to the database. So you want to make something that gets you from 0 to make magic happen as quickly as possible, right? You want to do something, right? And the first thing you think of is scaffolding. Scaffolding is great, right? It's the promise is that it's amazing and that it's productivity and awesomeness. And in a lot of ways it is. Scaffolding is cool. Scaffolding is magic, right? It's kind of the promise, right? And it's very easy to do, right? Let's take a tour. Let's take a tour of a scaffolded application, a scaffolded ASP.NET Web API application. In this case, it's core, all in Visual Studio, right? Because Microsoft provides all this great tooling to you. You might as well use it, right? So at first, let's introduce our friend, the employee object. Let's say you're a system that has a representation for employees, right? You have an ID. You have a first and last name that you notice are decorated with the required attributes because they're required data. And you've got a date of birth and a date of hire and a social security number. Wait, where am I? What the heck is a social security number? I made this mistake in London. I had this slide up and I was like, oh, I don't know that they know what a social security number is. I didn't make that mistake again. So I'm in Norway, so I'm going to talk about the birth number or the national ID number, right? Or that word, right? So the bottom line is that the employee object is an object that is part of a payroll system, right? Something like that. A lot of people deal with payroll. A lot of people deal with employee records in some way. And it contains sensitive data. In this case, I'll just say SSN, but national ID number, birth number, whatever you want to call it. It's sensitive data, so you need to treat it differently, right? You need to treat it in a way that you need to encrypt it, right? All that kind of stuff. So that's setting the stage a little bit, right? And you're the developer, you love Visual Studio, and you love Visual Studio's tooling, and you love to get stuff done. So what do? You go to File, New Project, and you choose ASP.NET Core, and then maybe you add Entity Framework, right? This is an opinionated talk. I like Entity Framework. You may use something different, and that's okay. You may use Web API plus something complete. You may use NHibernate, and that's okay, right? All of these things. So this is the core of your application, right? You've got something that processes requests, something that talks to a database. You go to File, New Project, and this is kind of what you're looking at. Now, for those of you, there was I think about half of people have looked at Core. There's a few things that are different. So first thing, and probably the best change I can think of, is now none of the static files and the code files and the views and the controllers, the CS files, right? They used to be in Web API. They're all intermingled. They're all together. And then ASP.NET and IIS just serves them up differently based on the file type, right? But in this case, now, Core, probably the number one improvement, maybe not the number one improvement, one of the number one improvements was moving that all to a www root. So all of your static data now goes and is served out of that folder, right? So if you've got script folder inside of the path of your directory, you have to do some kind of process to move those files over to the www root directory before they're served. So that's awesome. Other than that, there's really not much changed. You've still got controllers, models, views. Those folders stay the same. And you have this is a little different. So web config is a little bit, some of its functionality has been replaced with the app settings.json file, right? There's a couple other things, including the startup.cs. The startup.cs is a lot different now. How many people are familiar with global.asax and have to play in that file? Okay, most ASP.NET developers are. Anybody intermingle it with startup.cs? They have both existing in their Web API or MVC project. Okay, a few of you. So startup.cs has really taken the place of what global.asax really did, which is just like handle the startup of the application, right? You're handling the startup of the application, and you're defining in this file, this is a little different from startup.cs that you use in Web API, you're defining all the services that are used inside of your application, right? So this is all the stuff that Core needs to run, and nothing is put there by default. When you new up a Web API or an MVC project, the handlers for ASP.NET Web API and MVC, they run through, when you make a request, they run through, well, maybe this needs to handle it, no, need to pass it on to this, need to pass it on to this, right? It goes through a chain of processes, and it'll always run every time. And in ASP.NET Core, you don't have that. You don't need that. So you actually opt into everything. You don't even serve static files by default. You have to add in, you have to opt those things in, right? So you get to pick and choose what you want. But most people will start with just add MVC, right? And that'll give them all of this particular line will give them all of the services that their MVC application needs to run. It'll make their controllers work. It'll put in routing, all of that good stuff. It makes those things available to the ASP.NET Core pipeline, right? Okay. And then you notice a little bit different. There is an add DB context, which is an extension method on your app builder, okay? And that simply says, I want to make an application DB context available to my request pipeline as well. So that way, if a certain controller or service is requesting that, it will get instantiated with this connection string and injected right into that controller. And we'll see an example of that in just a second. But first, you notice, of course, we've got our employee object. Our employee object is now inside of our project folder. So we've added our employee model with all that code and the birth number, right? And then you're like, okay, well, now I've connected Entity Framework. So just as an example, right, because the tooling likes Entity Framework. So now we've got our model. Now we're going to add our controller, and we're going to scaffold, and it's going to be awesome, right? So you're going to right-click on your controller. You're going to go to add your controllers folder. You're going to right-click on it. You're going to say add controller, and there it is right at the top, ready. And then you're going to have a list of choices. And your list of choices is going to include, we're going to select the bottom one, right? So you can do empty read-write actions. You can just do an empty controller. You can do one that serves up views, an MVC controller. In this case, we're going to do an API. So we're going to select the bottom one, and we're going to say, hey, we're going to use Entity Framework with it, and we want to scaffold up all the read-write actions for this controller. So then you get a nice, handy little dialog box that says, pick your employee, pick your pick your application DB context you're using, and then say the name of the controller, right? It's that simple. And then you'll hit OK, and ASP.NET and Visual Studio actually will go through and scaffold up those controllers. It'll make one for you. And then you've got yourself a wild employees controller, and it's appeared in your solution, and it's awesome, right? Because it's got a bunch of stuff. So let's look at the first thing. The first thing that's a little different about it from when you did this in Web API. How many people used scaffolding in the past? A fair number of you, I'd say. Okay, less of you than I thought, but still a good number. So it's just code gen, right? It's generating all this awesome code for you, right? To get you started quickly. So it's got an employees controller. Right off the top, they're decorated with something like that says produces, right? And it says that by default, request to this produce application JSON, which is different. How many people, when they're using Web API, had to go through and the default serializer was XML and they had to remove it or make sure that when JSON, they wanted to serve JSON right as default by a default request. I see a few hands go up. You don't have to do that now. You can just decorate the controller and say, a request to this will produce application JSON. And then you say, I've got a default route. This is a little bit different. If you use route attribute, if you use routing attributes in Web API, this is a little different. Now it's just called route. And you say API/employees. Okay, and so all the requests from there on will look at, if you go to API/employees, then it'll route that request naturally. If it's a GET request, it'll route it to the GET. If it's a POST request, it'll route it to the POST, and so on. And then this is the biggest change, which is now the application DB context is now injected into your controller by the ASP.NET pipeline. Remember that inside of our startup CS, we injected that. We said we want to make this service available when you're running MVC services. We want to make this service available to all the other services that need it. So that's great. So essentially, when you make this request, you'll automatically get a new employees controller, and it will instantiate it with this application DB context already ready to go. Cool. And that's different from Web API scaffolding, where it would just new up its own application DB context, which is not as good, which is bad, right? Because then it's creating its own things. We want to tell it what we want. We'll get to that in a minute. Then we do GET requests, right? We get something where we just define something where we say, I want to get all employees for this controller, for all the employees for this particular organization. Okay, that's a good start. And for like maybe, a couple hundred employees, that'd be good. Maybe there's a paging option that you want to add in. We're not going to talk about that, but you look at that and you're like, okay, that's a good start. That's a good way to begin. And then of course just the single GET, where you make a request by ID. Maybe you say, does this person have access to this? Yes or no. Okay, then I'm going to go ahead and send that back. If it's an invalid request for whatever reason, if it's a GET request, then I'll return bad request and give them a nice little message. Okay, so that's the GET request. So then we get to the put request, which actually changes employees. Now I'm going to talk through this a little bit because this one's a little bit weird to me. This doesn't make a lot of sense. So what you end up with is, of course, if model state is invalid, return bad request. That's a good start, okay? But notice that what we're putting into this request, right? If you make a put request to this specific ID, and then you say, I'm going to give it this employee data, you notice that you're using the same entity as you're using the same model, your entity model, as the one for the request. Well, that could be good or bad depending on your requirements, right? And we'll get to that in a little bit. But then you say, I'm going to try it, and then it becomes, you get this little check on line 10-ish, where you say, if the ID that I've passed in is different from the employee ID that I've given in my request, then return bad request. And you're like, okay, why do I have to give that twice? Oh, okay, whatever, I'll just do that. That's fine. And then it says, I'm going to modify, it set it to modified, so Entity Framework knows to update it. And then it saves it to the database, and it updates it. Okay, all right, that's not so bad. Otherwise, we'll return, if there's a problem doing that, we will return a different error message depending on the problem, right? And then, of course, we get to the post request, which is a little bit simpler because it's just creating an employee, right? Then you're just adding it to the context, and you're validating it, adding it to the context, and then you're saving it to the database. Cool, right? And then, of course, the delete. You may do something where you're deleting it straight from the database. You may have a soft deleted kind of situation where you just want to mark it as deleted inside the database, but you don't actually want to get rid of it. By default, Web API gives it, just straight removes it from the database. And that's okay, right? That could be okay depending on your needs. So that's a scaffolded controller. So just with a few clicks, you've gotten something that's great, right? It's awesome. It's productivity. It's amazing. But I'm here to tell you that in many cases, as your application grows, scaffolding is a lie. Scaffolding is a lie perpetrated on you by Microsoft, and yes, I'm a Microsoft MVP, and yes, I can say that. But scaffolding is a lie. Scaffolding is something that is great to get started, right? But in the long term, it has some problems. Because your controller, first of all, is a one-man army. Your controller is now responsible for getting the routing a request, kind of. The ASP.NET router system handles that. But then once it gets to the controller's like, oh, this is the method I should use, right? So it's responsible for doing that, which is good. Controllers should do that. It should define where the request should go. But then it's also validating it, and then it's also running the service, right? It's updating the database, it's deleting from the database, or it's adding to the database, or it's even getting, right? It's doing everything. And then it returns the request, which is okay because that's what a controller is really good at. But your controller in this case is doing everything. And that's a problem because there's no separation of concerns inside of your application, inside of your controller specifically. Your controller is literally responsible. Now, maybe that's okay for 5 controllers, but 500, we run into some problems. But I'm going to describe to you ways around that, and it's going to be a refactoring exercise, right? We're just going to take you through how I would make it, how I would change this controller to make it better, okay? Because in the end, the controller should only route the request and return data. That's what it's good at. The controller is good at saying, hey, this thing knows how to do this thing, so I'm going to send this request to this thing so it can do what it does best, which is whatever thing it's requesting, okay? And then I'll return the data. I'll return whatever data that it asked me for. Another big problem, and this is probably, maybe, I don't know, this is a big problem to me. Your entity also is your request, right? Let's think about that. Let's think about that birth number, right? You may not want that to be something that you want to be updatable. Maybe that's a business rule. In a little bit, it will be a business rule. But in this case, you just don't need it. You don't want them have the ability to update it. So you just toss it away. You want to toss it away, right? You don't want that to be something that you want them to update. Your consumers are then able to, I don't know, overpost, right? They can change properties that they're not supposed to change if they're aware of them, things like that, right? Problems. So let's break it up. Let's break it apart into all the little pieces and parts that is necessary, right? So we're going to talk about something called command query responsibility segregation, okay? And this is a great pattern for basically separating the requests from the services that run those requests. And I'm going to take you through how you might break that thing down. The bottom line is that we're going to move the validation, the running of our service, and the requests. We're going to remove those all somewhere else, right? So we're going to move those out of the controller. The entity is no longer going to be responsible for being the request object, okay? And there's a few reasons why. Why is that good? Reliability, right? So, or reusability. And maybe, let's say that you have services that you define in another assembly, and Web API is just aware of them, right? And then it uses those services to route requests and do stuff. But you may not be able to predict where, HTTP is, where we do the majority of our work if we're a web developer. But you don't know. Maybe somebody else wants to use that service somewhere down the line. You may not be able to predict that. So then you get to be able to reuse your code, right? Next thing, separation of concerns. Okay, so now everything is really good at doing the one thing that it's asked to do. The controller right now is kind of good at doing the few things that it's been asked to do. But by and large, it's really, really only good for 1 or 2 things, and that's really where all of its functionality should stay. And then easier testing, right? So it becomes much easier to test these once you have these individual components, right? You can write unit tests for each of those different things and end up being able to control and predict where things are going to fail. Or if code changes somewhere down the line, then it will fail, it will fail faster that way, right? Unit tests. So let's start with the request. Let's break this baby apart, right? So same thing, same employee object that we have, and you notice that we have our validation inside of our employee object. More on that a little later. So again, the entity is being used for requests. That's a bad thing, right? Because again, for lots of reasons, overposting reasons. You may not want them, they may not be aware of properties on there, you may not make them aware of properties on that object that you don't want to send back. And then when they do a put request, they're not aware of them either, so they may void out those requests. In my other REST talk, I talk about where I do exactly that. I underpost data, or I underput data to a certain endpoint. And I didn't know that doing so would break their application, but it literally broke, and they didn't have any validation, which is a terrible rule anyways. But because I didn't send all the requisite properties that I was supposed to do, that I was supposed to send in this request, it ended up making putting the application in an illegal state, like a state where it just wouldn't run, right? There's a lot of reasons, so we want to break that apart. And then we want to separate the responsibility for model validation from the model, right? Something else is probably best suited to validate and make sure that that model is good, okay? So let's refactor. Let's start by separating the model from the entity, right? So we've got our employee object, but we've got our business rule that says that when we make a put request, we want to be able to have that employee be able to be made with a put request or with a birth number with a post request, right, when it's on creation. But we don't want that to happen when they update it. Now, this is a really simple rule, and you can write around this a little bit, right? But as we know, when we make requests like these rules can get infinitely complicated, right? These rules can be, the complexity of these can go far and beyond just this one little example, and it's hard to code for that. So let's not. Let's just make it very simple. So let's create something where we actually have something that actually creates the object for us. So we create an employee create request, right? So this is what we're doing here is we're breaking things down into one request class or definition, one request definition per request that we're making. So we're going to end up making a update request as well. And you notice that I'm just missing that property straight up. I'm not actually setting that property at all. It's not something that ASP.NET becomes aware of. Even if they post a birth number, it doesn't matter because it's deserialized as just an object that C# is aware of, but birth number gets thrown away, right? And then we can do a delete request where we simply just say, hey, we just want the ID of the request, and then something on the other end can handle that, okay? So another thing is those required attributes are a little clunky to validate, especially if you're not using ASP.NET, right? At some point, you may end up using something other than ASP.NET, and that becomes very clunky to validate. And this is an example of the clunkiness, right? So this is an example I pulled off of Stack Overflow. The link's at the bottom of this slide somewhere. And essentially, they've just done some attribute routing, but they needed some special behaviors, right? They needed some special things that they needed to do. They needed additional validation. But you notice that, well, okay, first you got to new up a validation result, and you implement this cool iValidatable object. And that's an interface that defines a validate method, and you essentially return them validation results. And if they're invalid, and one or more validation result inside of that set denotes an invalid object. So they try to validate that property, and you're like, okay, I'm going to validate this property, and then I'm going to new up a validation context, whatever that is, right? I thought I was already getting one, but apparently I'm going to new one up, and then I'm going to pass in null. And you're like, you look at this and you're like, is that good? Is that bad? Like, what am I passing in? Maybe it needs that thing. I'm supposed to avoid null reference exception, and you're telling me I need to put null into this? It's very confusing. The API is extremely confusing, and it's just not nice. So, opinion. Here's the opinion warning. I have a library that I use called FLUENT validation, and FLUENT validation is game-changing. Well, it's life-changing. It's maybe not as life-changing as like having a kid, but it's certainly more life-changing than this, right? It's more life-changing than this. This should just make you want it to not be a developer. So FLUENT validation is a really awesome library, and essentially what you do is you define a single class. So let's take our employee request first. We'll just boil it down to just the first and last name to keep it simple. So what you do is it's a separate class becomes responsible for validating that this class is valid. So we want to isolate that validation functionality. So what we do is we create what's called an abstract validator, right? Or we create a class that's an employee create validator and inherit from abstract validator. That's a class inside of FLUENT validation. And then we give it the type of the thing that we're validating. So that way we get strongly typedness as opposed to that new prop 1 stuff I don't even know, right? We don't have to worry about all that because now we just construct our object and then we say here's a rule. And here's the rule for first name. I don't want it to be empty. And empty is great because the required attributes are kind of funny in that there's actually if you pass in an empty string, that's technically valid, right? Unless you set on the required attribute there's a property you set, allow empty strings. You can set false and you can cover that, but you don't want to do that. That's a lot of typing, right? Forget about it. You want to just say, I want to make sure that this thing is not empty. And not empty means not default value, not null, and in this case, not an empty string. So it gives you, it better defines the purpose, right? You want a first or last name attached to that employee. It better defines the purpose of that employee, because the first and last name should never be empty strings either. So that's awesome. And they have a ton of methods that allow you to build different validation functionality. You could say it has to be equal to this. You could say it has to be a range of numbers, right? There's a lot of stuff built in. Personally, I discovered it by simply and looking at IntelliSense and seeing all the different rules that are available. And you can do some pretty complex behaviors, right? Some pretty complex validation, and it's better, way better than that mess that we saw. So then you say, I want to say that first and last name are required, and I want to give a special error message. And this is a part where resource strings really come in handy, because if you have to do English or Norwegian, because I'm in Norway, right? If you have to do English or Norwegian, you can use resource strings, and you can reuse those strings, and it becomes very nice. Cool? So now we've separated our validation behavior from our request. Our request is no longer responsible for also defining its own validation. And for a simple thing like first and last name, where you just need to say, I just want it required and I don't want empty strings, that's fine. But validation behavior can get pretty extensive, right? And we'll talk about that in a second. But first, we got to mention that testability, right? So now we can test our validator separately from our request, right? We don't have to create a separate request, new it up with a bunch of stuff, create some validation context where you're passing in 40,000 nulls and you don't know what that does, if that's good or bad. You can just say, I'm going to new up the validation request, I'm going to validate this object, and then I'm going to make sure that the validation errors have something that has a first name and a last name, right? And so that way when Johnny, junior developer, or Jane, junior developer, comes in and deletes that line of code, now you have a test to back that up, right? Because tests aren't really written for just today, to validate that things work today. They're also things that work tomorrow, for things that work tomorrow, right? You want to guarantee that behavior works tomorrow as well. So also your validators can have some complex behaviors. You may need to talk to a database to make sure that for your delete request that something exists. So you may need to add that to your constructor. And then you say, I'm going to pass in an application DB context, and I just want to make sure that it exists first. And then you get a cool API where you can kind of write it in English or in, whatever language you're writing it in, right? Or you could say, like, I'm going to define a method called exist in database, and then I call a method, Fluent Validator has a method called must. Must exist in database. It becomes very readable. It becomes Fluent. It's a Fluent API. That's kind of one of its design goals. So we've separated our request model from our entity, and we've separated our validation from our request model. So awesome. We've created two totally different things. So we've done some good work already. Refactoring, good. But next, let's get to the meat of it, right? So we've done very important steps, but now we need to extract those services. And for this thing, we're going to talk about the post request. For this particular example, we're going to talk about the post request, right? So it's doing all this work, it's creating this object, and of course it's getting the entity straight from the request, which is just crazy. You don't want that, right? So now we're going to make it so that we can save it to the database, but the controller doesn't know how. The controller doesn't really care, right? So next opinion, ding, 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 warning sign, something. It's like a big flashing red sign, opinion alert, right? So I use a library called MEDIATR. How many people use AutoMapper? Lots of people use AutoMapper. AutoMapper is automagical, okay? Look it up if you haven't. But AutoMapper is written by a guy named Jimmy Bogard. He's speaking at this conference. And Jimmy also wrote a library that's way lesser known, but in many ways just as useful. For different things, though. It's called MEDIATR, and it essentially is kind of like a message processing request inside of a process, right? So MEDIATR is really good at separating requests from handlers, request handlers, right? So request comes in, the request handler handles it, okay? And MEDIATR is really good at that. So let's look at that. Let's take a look at what that looks like. Let's keep refactoring our application. So first things first, we have our employee create request just as we did before with all the validations separated out, which is awesome. So that's good. So we do our employee create request. And then you notice that this little line right here, we've changed it. We've implemented an interface called iRequest. And iRequest is a special interface. It doesn't really do anything. It doesn't define behavior or properties. It's really a marker. That's what it is. And it says, hey, this object represents a request. iRequest is part of the Mediator library. So this object represents a request. And then you give it the return type. When you create the employee, it's the one thing you need to know probably that you might want to return to the client. The ID of the thing that you've created, right? Because it doesn't get to choose its ID. It's an auto-incrementing database. So you just give it the ID back. So that's all we're asking. We're saying, hey, this is a request, and it's going to return an ID in the response, right? So that's thing one. We've changed our request. So now we've defined, we're going to do step two, and we're going to basically do the same thing that we did, pulling out the validation, pulling out the request, but we're going to do it with the service now. We're going to handle the post request. We're going to save that thing to the database. We're going to create that new thing. And we're going to add that to the service. So we're going to define a service that implements this iRequest handler, okay? And you give it the request, and then the type of the request, and then the type of the response, okay? And what you're going to end up with is this little method here called handle, because it actually does implement some behavior. And handle takes in the request, and you notice that its return type is int, just like this, right? Just like the thing that we want to return. We want to return the ID of the object. Common question is, well, what about async await? There's actually an async request and async request handler. And then handle becomes a task event. Is that what it ends up returning? Okay? So async await, totally available to Mediator as well. So then we end up with our request that creates our employee. We set the properties from that request, and then we save it to the data. We add it to our context if you're using Entity Framework, which we are. And then we save it to the database, and then we return the new employee ID. And everybody's happy, right? Well, I mean, you're happy if you're writing plumbing code, right? Nobody likes to write properties like this. Objects, as we know, can get huge. I mean, that's just, especially if we're using legacy applications, we've got a God object and it has 100 properties. Nobody wants to type. Then you go to Nimble Text or some kind of text editor that allows you to like copy paste, and it's just a mess, right? And we don't have time for that. There's no time for that. We don't have time for that. We don't want to write plumbing code. That's not what we're here for. We're here to think. So we're going to use AutoMapper, right? So inside of this service, we're going to inject AutoMapper. And AutoMapper is a way to map objects from map objects together. So our employee create request in this case can be mapped such that all of its data can be transferred to a new copy of an employee entity, right? We just want to do this just to keep things easy. And AutoMapper does all the wiring for you. As the properties names are the same, then AutoMapper knows what to do, and it sets all those properties for you, and it's great. So you inject in your mapper. You can add it as part of in your services, in your service.cs, your startup.cs. You can add it in there and add it as a service that's available inside of your ASP.NET application, right? And then you can do something like this, which is a lot nicer. You can create an employee, and you've just mapped it straight from that, right? So save time. So that way we're not doing the whole property set thing, which you don't want to do and I don't want to do. And apparently scaffolding didn't want to do either. So that's awesome. So now we've ended up with a service, but where does it get validated? The service, so I like to implement a pattern where I create a common service base class. And I say all of the requests, all of the validators that go in for this request, inject those straight in, right? So we inject those straight into the constructor. And we say, I'm going to go ahead and validate all these. I'm going to run through each of those, and I'm going to check that if it's valid, and if it's not, I'm going to return some validation results or throw in this case, usually I throw a validation exception, right? I don't have the code for this because it couldn't all fit on the slide. If you go to rest.schneids.net, I link to a great Jimmy Bogart article that shows you exactly how to do it. Takes it step by step, okay? So we're going to do all of our validation, and we're going to register those validators inside of startup.cs, right? So it's going to be made available to that service to use, which is awesome. Cool. So now it's validating itself. So I create one base class that validates the request, and then I inherit from that with all of my services, right? And so I've created something that reusable and repeatable in a very lightweight way. I just want to make sure that my services are my requests are validated. And and another common question that I get is, multiple validators. Why would you just not have one? You may have a validator that's really good about validating some very complex things about your object that boil down to maybe touching one or two properties. I don't know. I can't predict that. You may want to break up your validators is the bottom line. So you don't want to assume that there's just one, so we add multiples. Because if you do assume there's just one, then a lot of dependency injection libraries will just return the first that it has, and you may not want that. So we do multiples. Awesome. So it becomes independently testable. So now this service is really good at doing its one thing. So we're going to test and assert that this service is really doing this really good one thing. And then, of course, it's reusable, which we described earlier. We may want to use it outside of an ASP.NET Core application, right? We may want to do that. We don't know why, but we may want to. It's more important that it be separate, though. That's the most important takeaway. So let's put it all together. Dependency injection handles dependencies, right? So the thing that where we configured all of our services, we added MVC to the pipeline, we added the application DB context, and now we've added in AutoMapper and a bunch of other services and a bunch of other validators to our pipeline, right? We made those things all available. So that's what it does best. It says this thing is dependent on this thing, so we're going to create that thing with all the things that it needs. Was that like enough things in that sentence? Then we're going to have Mediator do the request. We're going to define requests through Mediator, and then we're going to define responses through Mediator, right? Or in this case, handlers. The Mediator is doing that. It's really good at defining requests and handlers. And then controller will do what it does best, which is take an HTTP request, do something with it, send it off to somebody who knows what to do with it, and then return the data. That's what the controller's good at. That's what the controller's for. It's like a traffic. I like to think of a controller as a traffic cop. It just says, okay, you need to go here, you need to go here, you need to go here. Okay? The bottom line is the next thing is that dependency injection was never baked into ASP.NET Web API. If you're using Web API, if you're using Web API, you can add it in, of course. You can add dependency injection in very well, but it wasn't made a first-class citizen until Core. So, but I would highly recommend using a better dependency injection container. I personally like AUTOFAC. I see lots of people use Ninject. I see some use structure map. It doesn't really matter. Do something that just makes your life easier. In this way, I kind of use it like AutoMapper, and I'll show you how. AutoMapper or AUTOFAC will automatically scan your assemblies. You can say, hey, scan this assembly for all of these interfaces and just automatically add them to the dependency injection pipeline. Because you can define them one at a time, say, I'm going to add this service, then this service. But when you get to 100 services and 100 validators, that becomes pretty heavy. So you may not want to do that. You may be like me and just want to get stuff done. That's what I love to do, is get stuff done. So we're going to do something like this. We're going to change our startup.cs file a little bit. We're going to say, hey, I want you to create this. I want to create this container builder, which is an AUTOFAC thing that is built into AUTOFAC. I'm going to new that up, and then I'm going to say, hey, I want to scan every service assembly, because you may have your services in a separate assembly. You may not. Depends on what you want to do, right? You want to scan that assembly, and you just say, I want to register all the types as implemented interfaces, right? And this just goes through every single type, and every time it has an interface, it says, okay, this is an iValidator, so an iValidator that validates employee create request. So when something is asking for it, it gets injected in, right? You can also filter this down, because you may not want that behavior. You may want to filter only the things that implement iRequest or abstract validator or async request handler, something like that. Okay. So do something. Save yourself some time. Don't do them one at a time. Use AUTOFAC. Use something awesome, right? So then the thing that you need to do is make sure that Mediator. So you'll need to register Mediator as part of this whole process. Mediator is a thing that is actually an object that is created that actually handles that request. So we're going to add it to the service pipeline, and then we're going to add it to the controller so that the controller knows who to ask for things, right? And knows that, oh, the Mediator is the god of all requests. It knows, I don't know, I just present the request at the altar of the Mediator, and then the Mediator blesses me with the response to that request. It takes that create post request or create employee request and routes it to wherever it needs to go, and out comes an ID, and who knows if it actually created something. I don't care, because I'm the controller. I don't really want to know, right? So we add that in. Of course, we would add in our application DB context here as well still. I just left it out for brevity. And then finally, our controller. We've refactored. So let's break this down. We've refactored the request. We've taken the request, separated it. We've taken the validator, separated it. We've taken our service and separated it from the controller. So now the controller is not left doing much, which is great. This is the thing the controller should do, right? So we say, hey, Mediator, handle this request. Again, I don't know what it's doing. I just know that you're going to return an ID, and that's awesome because I'm going to assume that it went to a database and happy flowers are growing and everything is good. Everything is good and great, right? We handle that request, and then we say, hey, created an action, right? We want to return. The controller's good at saying, hey, HTTP request, here's a response, right? Here's how you get that new employee that you just created, right? And that's good. And then if we have any validation, you can say, hey, I'm going to throw an exception. I'm going to catch this validation exception and say if there's any validation errors thrown, I'm going to go ahead and return bad request. And then I'm going to give it something with model state, which this is just an extension method that I define myself. If you want it, you can ask me for it. I don't have a post anywhere. I will do that, though, in the next couple of days at rest.schnides.net. But essentially, it just creates a model state and just adds all those error messages to that model state. Okay? So let's wrap up with a few tips, okay? My thing is creating repeatable patterns. I like to create repeatable patterns for success. So part of my job is I own a consultancy and I have a junior developer, and giving her patterns to repeat, right, to something, because she's definitely new at development. So I give her patterns. I say, hey, do this formula and follow this through. And this becomes really powerful when you're training junior developers, because now you don't have to say, scaffold up 400 controllers for these different objects, right? You can just say, hey, I want you to do this methodically, and we want to build software right, especially if it's an API that somebody else is consuming. I've consumed tons of bad APIs, which in my other talk you can hear me tell all the horror stories. But imagine how powerful that becomes, right? You say, hey, let's do this one step at a time. Let's break this down. We're going to define our request. What is our thing going to do, right? What is the data that our thing needs to do? What data does it need? And then I'm going to say, hey, let's validate that request. I'm going to give you a list of business rules, and based on that, ask Fluent validation to say, hey, ensure that this string is empty. Ensure that this number is between 0 and 100, right? And possibilities are endless there. And then you say, define a service. And then you say, hey, now we have our request. We've validated it. Let's inherit from this base service that we've created that automatically hooks all the validation up. And then you just implement the handle interface and then save it to the database, delete it from the database, whatever, right? It becomes very powerful because you've broken it up into finite steps. And you're unit testing all along the way to make sure that your validator works properly, that your service is going to work properly, right? Because we all do unit testing, right? Right. The better, more complete example, Jimmy Bogard's blog, right here on this link. Go ahead, I'll wait. You can click on it. Okay. Well, when you get to the slides, you can click on that link, and it's right there in the links that I provide as well. Okay. Write tests for everything. I can't emphasize this enough. I have no exceptions to that rule. I just think you should write tests for everything. And a lot of people think that this slows them down, but it doesn't. And there's plenty of people who give good talks on why testing is important. So I'm not going to beat it into your head. I will just say that it becomes, the thing that is powerful for testing for me is that it becomes a spec. It becomes the way your software should behave. It becomes, and not only does it become the spec, it guarantees that spec stays the same. So that when Jimmy, junior developer, comes in and deletes that line of code, the whole build comes crashing down because you failed that one unit test. And by the way, that functionality was really critical, and you have some consumers of your API that really suck, like me not sending enough data to that put request, right? They didn't validate it. I didn't send enough data. Everybody screwed up. So avoid that. And I can tell you, by the way, that the particular API that I used that had this problem, I talked to them. It was ASP.NET Web API, and no, it wasn't backed by a single unit test. So they had a lot of breaking changes between their behavior. I think that my favorite example of that was in my other talk. They said, oh yeah, we changed some stuff that happens under these couple of endpoints. Nothing really changed from a request standpoint. Just let us know if you have any problems. We just changed some underpinnings. And we said, oh, okay, we want to run our suite of integration tests to guarantee that stuff still works as it advertised. And they said, actually, we're deploying in 1 hour because we need it right away. And they're like, well, and then you're stuck saying, well, I don't know. We have about 500 customers that depend on this API working properly. What are you going to tell? Do I want to tell them? Why don't you have the conversation with them in case your API gets screwed up, right? And by the way, nothing broke that time, but they had other times where things broke. So write tests for everything. I like to keep versions separate. This is another kind of opinionated thing. But if you're creating a REST API, you're probably going to version it, right? And I talk about all the strategies behind that in my other talk. But the bottom line is that you may have services that where the employee only takes a certain number of properties, or maybe you rename properties from the next version of that, or you add in some behavior, right? So I like to separate those into separate versions. So I have a separate assembly, right, where I keep all those things. I say, here's my separate version. I'm going to say version one services, scan that assembly, put in all those services. And then the version 2 of my API, because lots of APIs are versioned. If you're doing a REST API or any kind of API, at some point you'll probably version it as well. And then you can keep it in a separate assembly, and then you can just add those to the pipeline, and that way everything's kept nice and separate. And then you have another separate test project as well, right? Keeps everything nice and neatly organized, which is great. So are there bad sides to this approach? I think there are, right? So it may be unnecessary complexity. If you're spinning up a website, they say, actually, we just want a newsletter. We just want to be able to send a newsletter, right? And you're trying to get something done quickly. You really just want, you don't care about that. It's not business critical. They just say, we just want a place for the text box and a button, right? That may be unnecessary to do something like this, to implement this huge amount of patterns, right? I mean, because the bottom line is we don't want to spend a lot of time doing that newsletter where there's 2 controllers and all they're serving is static data, except in this one instance where it does a post request. And you're like, I don't know, I don't care. Because, like, I mean, you can do all that stuff, right, apply all those patterns, but you may be just spinning your wheels. You may be doing something that doesn't have a lot of value. And your boss probably will forget about it next week anyways. And then, of course, there's a bigger learning curve. And I'd say this one is arguable because there's kind of a little bit of a learning curve in breaking down how the controller handles things. At the surface, it seems pretty straightforward, right? It's talking to a database. It's, deserializing a request. It's routing that request, saving it, doing some stuff, right? So the cognitive load, as your controllers get more complicated, the cognitive load can increase, right? So this, I mean, you have to learn some more libraries. That's the bottom line, you do. But once you get to that point, things become simpler. Your code becomes simpler. Everything kind of simplifies because everything is doing the one thing that it's really good at doing. It's really good at being a request. It's really good at being a validator, right? That kind of stuff. I find that this is best for medium to large size applications. So if you know your application is going to grow, you said, well, the newsletter endpoint isn't enough. We need 14 more endpoints to handle some very specific customer behavior. You may go back and say, well, I may refactor or I may apply this pattern, right? Because I want to have some strong guarantees about this is a customer-facing thing, or it's an internal-facing thing that's business critical. And I want to have some strong guarantees that it's going to function the way that I've said it's going to function. So I'm going to go through and apply this pattern, and you'll be rewarded for that, right? You'll be rewarded intrinsically because you'll know it'll work for the most part. And then reliability, right? You don't have to worry about controller being the single source of failure. Now it's of course, entity framework or not talking to the database. Maybe the database server is down. It's the true source of failure, but it's kind of masked, right? Because the controller is the one responsible for knowing all that information, right? You throw an exception, and then you have to go in and say, well, it threw an exception at employee controller line 23. So then you dig into the code, and maybe your logging isn't good. You dig into the code, and you look at line 23, and you're like, oh, that's the part where it saves it to the database. I should maybe start there, right? Whereas you might be able to start a lot simpler. You're like, oh, it failed at the validator for X, Y, and Z, right? Makes things a little less obscure. And it makes your code cleaner, and that's a good thing. This is really, I don't have anything else to say except all these resources, everything that the links to all this stuff, rest.schneids.net, take a picture, look it up later. Again, I answer questions all the time about this kind of thing. People reach out to me all the time, happy to give free advice. So please reach out to me on Twitter, and usually I'm gonna save questions at the end in case anybody wants to go down and join the awesome party that's about to occur. So any questions, you just come up to me on the stage, and I'll be happy to talk you through your particular problem. But the bottom line is thank you so much for being here. Again, please reach out to me. Go to my website, reach out to me. Again, I don't make any money on this, no ads. I just want to help you. If you have any questions, please feel free to reach out. I'm at Schneidenbach. sas@me.com is my email address. Just go to my website. You find all that. So thank you so much. Again, my name is Spencer Schneidenbach. It's been a pleasure talking to you. Thank you.